Hello. What I'll do today, I'll show you how to extract information from a data set, starting step by step by step. I have a data set here, 50 prices of tune-ups. So the variable is price of 50 different cars for tune-up costs. So like number nine, first one is 91. So it took $91 for tune-ups with parts. Then 78, 93, 57, 75, 52, 99, 80, 97, and then 62. So we have 50 data sets starting from 91 all the way to 73. I didn't write all the numbers, but you will have these numbers. I'll send it to you. So this is my data. Now I want to analyze this data. The analysis of this data involves statistical equations. First thing I'll do, I'll make a stem and leaf display. Like number 91 has 9 tens and 1 units. So the stems are like 5, 6, 7, 8 up to 9, 10. And then the leaves are the numbers, unit numbers. So I'm going to start from 91 and then go this way all the way to the end to write down in this stem and leaf display. 91 means 9 and 1. 78 means 7 and 8. And then 93 means 9 and 3. And so on. I go this way so I don't do mistakes. You don't need to do twice. Then you have second row. I wrote with a different kind of pencil, pen. Like this is 71. 71 is this one, 71. And then 69 and so on, until I completed the entire set. So my data has been transformed to this stem and leaf display. I didn't miss any information. I can go back from here to there, as I came from there to here. So without missing any information, I have gained some information. Like I know now if I want to find the minimum, I should not go anywhere except this first stem. If I want to find the maximum, I should go only to the last one, and so on. So this is an improvement on the data in terms of analysis called stem and leaf display. Now I have to find out a particular distribution, like 50 to 60. I have 2 numbers. 60 to 70, I have 13 numbers. And 70 to 80, I have 16 numbers, and write down this way. In here, 50 to 60, I have a star mark. That means 60 is not included, but 60 is included in the next one. 59.99999 all the way, it is inside. The moment it becomes 60, it is in the second class, and so on for all of them. So I have a now called distribution, frequency distribution table here, where these are the class intervals, and these are the frequencies. Now I have lost some information. For example, I know there are 2 numbers between 50 to 60, but I don't know what the 2 numbers are. So if I want to find out some more information, I have to think the midpoint, which is 55, would be happening twice. That way, I'll minimize the mistakes. So from here, I can find out a pictorial presentation of the data, which is 50 to 60, height is 2, 60 to 70, height is 13, and so on. So this is a frequency bar diagram, basically. It's called histogram because the bars are connected for continuous data. So when the continuous data is used, bars are not separated. In this case, 50 to 60, 60 to 70, and so on, all the way to 110. So we call it histogram. The first thing was data. Second thing was stand and leaf display. Third thing was frequency distribution. Now I have the histogram. Now, as I said, that midpoint represents a class. So on the midpoints on the histogram, I put some dots and I connected them together. So that is a zigzag form of the distribution where these lines are changing from class interval to class interval. So these zigzag lines, we call it frequency polygon. Only thing is that at the first one, we connected to the x-axis, assuming there is no frequency there. The last one is same thing. So it is a closed frequency polygon now. And it has it has 1, 2, 3, 4, 5, 6, 8 sides of the polygon. If you count it, you'll see. That frequency polygon is the shape of the distribution of prices, the costs, based on this data. Now, if I had not only 50 numbers, if I had 50,000 numbers, I could minimize this class interval shorter. Still, I would have frequencies. And then zigzag points would be smoother. This would not be that abruptly changing. It will become a smoother distribution. We call it asymptotic distribution of the cost of tune-ups or parts. So I have come from this data to this form of the distribution. For every data, you'll find this. It could be this type, or it could be this type, or it could be this. Depending on whatever data tells you, you have to go by them. In our case, it is this. Most of the numbers are small. Some numbers are big. We call it skewed to the right. This one is skewed to the left. In this case, most of the costs are smaller. It's cheaper. Some are more expensive, but most of them are very good. So you can figure out as an interpretation of the data from this data. The interpretation is that most of the costs are small. So you can feel comfortable going there if you want to save money. Now, if this is the exam scores, in this case, the exam was difficult. Most of the people did very poorly. If this is the case, and exam scores are these, not costs, then most of the students did very well. If it is a cost, like tune-up costs, that means this place has higher cost than what we expected. And if this is the case, it's not too costly, not too cheap, normal. So that is what I want to show you, the transition from the data to stem and leaf display, from stem and leaf display to frequency distribution, from frequency distribution to histogram, from histogram to polygon, from polygon to distribution. Remember, distribution is under the assumption that you have many, many data. You're just thinking that it should be looking like that. There is no database in this case. And at the same time, you can envision how the distribution should look like. Then you find out the skewness. We can compute these Q&As mathematically based on this data, which I have shown you in another video. But I just wanted to let you know that how we analyze the data and make interpretation very simple way. So if you have any questions, please feel free to contact me, make an appointment with me. So we'll go over them. Okay? Thank you. Bye.